Hi everyone, today I'm going to talk about Ohm's law. What is Ohm's law? Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. The formula of Ohm's law is V equals to IR, where V is equals to voltage, I is equals to current, R is equals to resistance. The SI unit for voltage is V, current is ampere A, and resistance is ohm.
Zombie apocalypse.
Now, we move on to procedures. Part A. This is the diagram given for us to build the circuit. But first, we have to click the link provided. This is how the link looks like. The first step is to delete the circuit and click draw and add in the components needed. The circuit should look like this. Move on to the first table, table 1. You can see that resistance is constant 100 ohm and the voltage changes from 3, 6, 9 and 12. So the one we measure is the current intensity measured in the website, and the current intensity theoretical we use the formula to calculate later on. Back to the circuit, you can see that the resistance they want us to put is 100 ohm, which is 100 ohm, and the first voltage they want us to put is 3. So we put 3 here. We close the circuit and we click run. You can see the reading of the ammeter is 30 milliampere. Put the value in the table and then you don't change the resistance, but you change the voltage to 6 as stated in the table. Click OK and click run. You can see that the ammeter has a reading of 60 milliampere. Continue the same step for 9 volts and 12 volt. These are the values you should get for current intensity measured: 30, 60, 90 and 120. Now we move on to how to calculate the current intensity for theoretical. We use back Ohm's law, V equals to IR, where R is equals to V over R. For example, for the first one, which is 100 ohm and 3 volt, I is equals to V3 and R over R 100. So you'll get I is equals to 0.03 ampere. The unit they ask us to put is milliampere, so you'll get 30 milliampere. Moving on to part A, table 2. You can see that voltage is constant, which is 10 volt, and resistance changes from 68, 100, 1000, 4700 and 10,000. The one we have to measure is the current intensity and calculate using the formula for current intensity theoretical. Back to the circuit. The voltage they ask us to put is 10 volt. So we click this one, we change to 10. Click OK. And then they want 68 ohm. So we change to 68. Click OK and you just click run. The reading of the ammeter will be 147.059 milliampere. Write down the value inside the table and then you stop it. You don't change the voltage, but you change the resistance to 100. And you click run again, you will get 100 milliampere for the ammeter reading. Continue doing for 1000, 4700 and 10,000 resistance. These are the values you should get for current intensity measured. So now we do the current intensity theoretical by using the formula same, which is Ohm's law, V equals to IR, where I is equals to V over R. So for the first one, I give the example for 10 volt and 68 ohm. I is equals to V10 over R, 68. Calculate and you will get I is equals to 0.147059. They want in milliampere, so you change it to 147.059 milliampere. For both of the tables, the current intensity measured and the current intensity theoretical should be the same. This is how you do part A for table 1 and table 2. Thank you.
Click on Zombie Apocalypse.
We continue for procedure part B. Firstly, you need to go to website that's given in the lab, and then at the website you need to set up the circuit as shown in figure 4, and X is a resistor agreement shown in figure 3. Okay, after you done draw the circuit and then set the voltage is 12 and then close the switch and then click run the simulation. Okay, after that you record the result in the table for the part B. Okay, and then you record the result. You have to add simulation at website to the table for the number 1. Okay, for the number 2 you need to calculate the resistance. For the first resistance is 100 and for the 2 resistance is 200. The resistance for 200 and run the simulation and you get the photo current is 50 milliampere. To record the result in number 2. Also same, you need to do for number 3, 4, 5 and 6, and then you calculate the last part is 1 over I. I you can get is from the current intensity is 85.714, and then you need to divide it 1 over 85.714 and then you get 0.0117.
So for the part A, question 1, what is the relationship between voltage and current intensity and resistance? Current intensity is directly proportional to voltage. Second point is current intensity is inversely proportional to resistance. It's related between V and R to current intensity. So for the question 2, asking for from the relationship of the theoretical values for resistance, voltage and current intensity, is it possible to recognize a mathematical relationship? Describe this relationship both in mathematical and written form. As we know, in Ohm's law, we using VIR, which is voltage equals to I is current times the resistance R. So the point is, when I increases, V increases. And next, when I increases, R decreases. So which means when current increases, voltage increases also. But then when current increases, resistor decreases. So this is how the question 1 and question 2 asking for, and the answer. Thank you.
Question 3. By using Excel, plot a graph of voltage V vs current intensity I, both for experimental and theoretical result. Both experimental and theoretical result for table 1 part A. This is for the table for part A in the table 1. The graph is directly proportional. Okay, this is both experimental and theoretical result for table 1 part A, and this is the result that we can get for the theoretical result. And this is the graph voltage vs the current intensity. You can see that current intensity is directly proportional to the voltage. Okay, this is the both experimental and theoretical result for table 2 part A, and this is the result that we can get, and this is the graph that we can get from the table 2 part A. Question 4. Using your diagram, determine the value for the current intensity at a voltage of 2, 5 and 7.2 volt. Okay, this is the answer. From the graph, when voltage is equal to 2 volt, the current intensity is 20 milliampere, and when the voltage is 5 volt, the current intensity is 50 milliampere. And then lastly, when the voltage is 7.2 volt, the current intensity is 72 milliampere. The last question is the question 5. Calculate the following using the formula of Ohm's law you have worked out. A. What is the resistance value of lamp with 4 volt at 0.04 ampere print on it? The answer is we using the precept of the Ohm law, where is V equal to IR, and then the question asks for the resistance, so R equal to V over I. V is 4 over 0.04 ampere equal to 100 ohm. For B, what is the voltage applied to a 1 kilo ohm resistor when a current of 18 milliampere flow through it? So apply to the Ohm's law, V equal to IR. 18 milli times 1k is equal to 18 volt. For C, how high is the current intensity flowing through a resistance wire of 200 ohm when a voltage of 8 volt is applied? The answer is 0.04 ampere. Thank you. That's all for today.